welcome back to this amazing channel. This is Abhinav. From last 2 years, I'm making these video editorials of Codeforces, Codechef, and Leetcode Contest. And you guys have shown a very great support in my videos. So first of all, thanks a lot for that. And these regular CP contests, participating and practicing these questions helped me also to crack good companies like LinkedIn, Zeta, and Geeks for Gigs. And this all was possible because of a proper mentorship and because I solve these problems regularly. I do upsolve the problems and I do solve problems of lead code and code force. So if you're also someone who is preparing for CP, who is preparing for interviews, who is searching for internship, but facing difficulty with you are not able to increase your rating, you're not able to solve problems regularly. If you are facing any such difficulty, we have recently launched Coding 75 Pro, where we provide one-to-one mentorship sessions and live classes of CP contest discussions, DSA classes, live project building classes, and CS fundamental classes. So it's a complete pack of your interview preparation. So if you are watching this video editorial of Codeforces, Codechef, and Leetcode, and if you want to also join the live discussion of these same contests with me, along with that, if you want one-to-one mentorship with me on CP, on DSA, on interview preparation, or in general anything that you need, you can check out the Coding 75 Pro subscription. The link is in the description. The whole schedule of the course is also present in the description. You can check that. The cost is very efficient, just 499 per month. That's it. But if still you have any doubt regarding our Coding 75 Pro subscription and how it can help you, you can DM me on my WhatsApp number, which is given in the description. You can DM me directly. We will talk about what are the difficulties that you're facing and how Coding 75 Pro can help you. So do join it now. Thank you.
Hello guys and welcome back to this amazing channel. This is Abhinav. In this particular video, we'll discuss about the problems of this contest, weekly contest 398. So we'll discuss all the 4 problems like A, B, C, D of the contest 398 of Leetcode, right? So I will say that the problems were really good. Like first 3 problems were not, that much difficult, I can say. The first 2 problems were really, of good level. Third was also, a basic level, like there was no DPO graph in the first 3 problems. So they were mostly of, greedy and array all, hashing all is included. The problem number D was a good problem actually. So I have actually tried solving this problem using 2 ways. First is a DP way, which was little complex. And second is a way using, some other method of number theory and maths, right? So we'll discuss both the methods to solve this particular problem. Let's discuss the problems one by one. So the very first problem is spatial array one. This was a really easy problem. The problem says that you are having an array and an array considered to be spatial if no 2 adjacent elements have the same parity. Means if they contain different parity, means it is a spatial array. What is parity? Parity means if they both are odd or if they both are even, that means they are same parity. But if one is odd, one is even, that means different parity, right? So if I will take an array, let's say the array is like this, 3, 2, 1, 8, 5, 6. If you will see, this is actually a spatial array because odd and even numbers are present in alternative manner. This is odd, this is even, this is odd, this is even, odd, even. So it is a spatial array because no 2 adjacent elements have the same parity. No 2 are odd or no 2 are even also, right? But if I will take the array like this, if you will see, let's say the array is 5, 1, 8, 6, 2, 9. Up here if you will see, if I will write this is odd, then again we got odd. Here only the problem is wrong. But if you will even later check later, this is even, this is also even, this is also even, this is odd. Means it is actually not a, spatial array. Okay? So this is actually a spatial array. This is actually not a spatial array. These are the 2 things that we are actually covering in this particular question. So if you will see, what I am doing here is, we are simply saying that I iterate through the array from index number 1, and for every index I check its adjacent, means its previous number. So if nums of I mod 2 is equal to nums of I minus mod 2, that means they have the same parity. So at the same time return false, means it is not possible. Else return 2 means they don't have the same parity, they have different parity, right? That's the another thing that we can do, right? Amazing. Now guys, if you will see the second version of this problem, here the problem is little different. The problem is same, we are having an array and the spatial array is considered same, everything is same. The thing is, now we don't have to check this for the whole array. Now we have to check this for a particular query, for a particular subarray from a index x to index y, let's say. Okay, if you will see here, let's say, let's take example of an array. So just give me 1 minute. Let's say the array is like this. Okay. Now if you will see this array, this is the indexing of the array. Okay. If you will see if this whole array is special or not, we will simply say false. Why the whole array is not special? Because if you will see even the first two indexes, they have the same parity. Means they are actually not the same, right? Up the problem comes where we have the queries. Let's say that we have three query. First query is from index number 1 to index number 5. Means from 1 to 5 is the array, is this array is special or not. Let's say second query is from 2 to 7. Let's say third query is from 1 to 8. Okay, so how we can actually check it? So guys, what I will do here is I will first of all create a prefix array, and this prefix array will initially be 0. Okay, now for all those indexes, which actually have their same parity as their previous index, you can see what I'm doing in the prefix array. Up to go here, whenever this type of question comes, when we have a subarray, right, what we usually do, we usually use prefix array, because to find the sum of a subarray, what we do, prefix. Here we don't have to find the sum, but we have to find that, okay, in a particular subarray, whether there is a, you know, same parity numbers are present or not. अब how we can actually find it? See, how we can actually find it is, we will say, okay, first we got a prefix array with the all the values 0. For every index I, which is actually equals to its previous index, means parity of I is equal to parity of I minus 1. Means there the special array is not exist. Means that particular index is actually, you know, not following the rule of the special array. So I will increase the value of prefix I for that particular index. I will say 0 will be 0 only, because for 0 there is no previous index. From 1 we will start. This will actually become 1 by, because its parity is actually equal to its previous parity. Its parity is actually equal to its previous parity. Means this will become 1. 1 basically means, simply means that, okay, at this particular index there is a violation of the special array. Up, see, this will be remain 0 because there is no violation. There is also no violation. This is, it is even, it is odd. It is odd, it is even. Odd, even. Odd, even. Here again the violation comes, because this is also odd, this is also odd. There is no violation here, there is no violation here, right? So means we got two violations at this index, at this index. Okay, but again we don't have to check like a specific index. We have to find, okay, in which region, from which index to which index of these queries do we have the violation. For example, if we will say from index number 1 to 5, if we will see from 1 to 5 there is 1 present. But if you will eventually see for this array from 1 to 5, there is no violation. It is actually a special array. But why still there is a 1? Because this 1 is because of this 7 and previous to it. So we will just take from here to here. If from here to there is no violation, that means it's a fine array. For that, what we will do, just like we find the prefix array sum, we will create a prefix sum array from like, so it will be 0, from here to here it's 1, then 1, 1, 1, 1, 2, 2, 2. So now it's a prefix sum array. I have changed the same array to this. So if you will see, I have converted the same array into a prefix array. Prefix I plus equal to prefix I minus 1. Okay. So this same array, I will remove this. Okay, let's keep it as this. This array was converted to this using the prefix sum technique, right? Now using this, we can actually find, okay, in a particular subarray, if there is any value which is 1, that means simply there is a violation. And if there is no value with 1, all are 0, the whole sum is 0, that means there is no violation. For example, first we are finding from 1 to 5. From 1 to 5, what we will see, first of all we get the value of prefix of 5. Okay, from this prefix of 5 I will subtract what? Prefix of 1. You must be saying, okay, Abhinav, you should subtract prefix of 0 because 1 is included. But we will actually subtract prefix of 1, because when we are considering prefix of 1, that is the violation of 0 and 1 index. So you have to actually subtract that because we don't want 0. We want from 1 to 5. So देखो 1 and 2 case is handled here, 2 3 case is handled here, 3 4 case is handled here, and 4 5 case is handled here. So we have to just need from 2 to 5. That's it. Because 2 is also handled in the 1 case. For every I index, we are checking the I minus 1 index, right? So for checking, okay, from 1 to 5, if there is any value with more than 1, we will simply find the value of prefix 5 minus prefix 1, which is eventually 1 minus 1, which is 0. That means in this region there is no violation, and you can see there is no violation. So if this value is 0, we will simply say answer is true. But if you will see the second case, 2 and 7. So for prefix of 7 minus prefix of 2, the value is 1. Because from 2 to 7, you can see there is one violation happening between 5 and 6. So here the answer will be no. Similarly, from 1 to 8 also, there will be a violation happen. But if you will say, let's say 6 to 8, if you will say 6 to 8, so prefix of 8 minus prefix of 6 is 2 minus 2, 0. Because here to here there is no violation happening. It is actually a special array. So guys, this is how we can actually find it for a particular subarray if it is special or not using this technique of prefix sum, right? So it's a very great way of solving this problem. So if you will eventually see here, what is happening here is we are having two things. Okay, so first of all, we are for every index I which is not following that property, we are making it 1. Now for the prefix sum, we are going like this. Okay, for the prefix sum we are going like this, and we are converting this prefix array into the prefix sum array. Okay. Now what about this answer array? In this answer array, I'm first of all going through all the queries. I'm taking x to y. That means we have to find for x to y. As I told you, the value will be prefix of this second value minus prefix of this first value. So means prefix of y minus prefix of x. If this value is 0, that means there is no violation in that particular range. We will push true. Else we will push false. And finally our array will be returned. Right? So guys, this is how we are solving this problem. Here also the time complex is order of n, and space complex is also order of n. Right? So both are order of n. That's how we are solving here. Right? Amazing. Amazing. Now let's move forward to the next problem. I hope that you have got the understanding of this problem. But still, if you have any doubt, you can ask that to me in the comment section, or you can join our Telegram group to ask your doubts. Amazing. Let's now move forward to the next problem. So next problem is actually a problem called sum of digit differences of all pairs. So we are having an array of positive numbers. Now what is a digit difference? A digit difference is a difference between, is a count of different digits at a particular position. I will tell you what it is. You have to find the sum of digit difference for all the pairs of integer in nums, right? Let me give you a first understanding of this problem. First of all, you have an array, and all the numbers in that array have the same size, right? Same number of digits, right? Let's say the numbers are 183, 213, 517, 128, 517, and let's say 288. Okay. If you will see, every number has 3 digits. Okay. You have to find for how many digits they are not same with any other number. Let's first talk about this first digit. Like this first digit of every number means how many pairs are actually not equal. You have to find for every such digit, right? So for first digit of every number, let's find. So you can see this one is actually not equal to this, and this. Means this one is not equal to 4 of the numbers. Means in your count, what will happen? 4 will be added. And guys, not just only for this one. For this one also, these 4 are the numbers where it is not equal to the 1. So again, one more 4 is added. Similarly, for this 2, if you will see, for 2, 1, 2, 3, 4. Again, 4 are the numbers with which it is not equal. This is equal to this 2. So again, 4 is added. And same for this 2 also, there are 4 numbers where the first digit is not 2, means they are different. So again 4 is added. ठीक है. अब next is 5. For 5 again you will see there are 4 digits because 1 is again having a 5. So for this 5 also there are 4 digits. For this 5 also there are 4 digits. Total we got answer as 24. If you will take every pair of numbers, let's say 183, 213, then 183, 517, so on for every digit. So if we talk about just the first digit comparison, there are 24 such pairs where the first two digits are not equal. There are 24 such pairs. But obviously, we will not do it like that. We will not just check for every pair. It will be order of n square time complexity. So how we can do it? So guys, how we will actually do it is we will first of all take the first digit. Okay. What I will do, I will find the frequency of every number in the first digit. You can see, if you will see, I will take a map. In this map, 1 is present 2 times, 2 is present 2 times, and 5 is present 2 times. I'm talking about the first digit only. Okay. Now let's iterate to this map. Ab dekho, 1 is present 2 times. 1 is present 2 times. And total there are 6 numbers. So 1 is present 2 times. And total there are 6 numbers. That means 4 numbers are there which are not 1. 4 numbers are there whose first digit is not 1. And 2 numbers are there whose first digit is 1. So total pairs having different digit will be 8. मतलब एक में 1 है और यहाँ पे there are 4 digit which are not 1. Total pair कितने हो गए? Total pair will be 8. Are you getting? So like 4 for each digit with 1. Same for 2. 2 is present 2 times and the number which are not 2 are present 4 times. Again here it will be 8. So it will be actually MP of I, means the digit that we are considering, multiplied by MP of n minus I. n minus I के कितने या फिर और sorry n minus MP of I, क्योंकि how many times that digit is present and how many numbers are there which don't have that digit. So we will map them because those are the number of pairs which actually have that digit difference, right? And same do for every digit, not just for the first digit. Okay, do that for the second digit also. For second digit, if you will see how many times the number is present, so you can see that 8 is present 2 times, 1 is present 3 times, and 2 is present 1 time. Okay, so if you first of all talk about 8, there are 2 numbers who have their first digit at 8, and there will be 4 numbers who don't have their first digit at 8. So overall pair will be 8 possible pairs. You can see how 8 possible pairs. So one is this, they can be mapped with this. Second, this can be mapped with this. There are 8 possible pairs, right? Similarly, for 8 is done. Next comes 1. So 1 is present 3 times. And number of pairs which are not 1, a number of numbers which are not, whose second digit is not 1, are also 3. Right? N minus 3 is also 3. Total will be 9. And same for 2. So there is only one, number whose second digit is 2. So remaining all can be paired with this. So remaining are 5. So 1 into 5 will be 5 only. Right? So this is how actually for every digit we will find that and we will calculate the count. Okay. So how I am actually solving this problem is, you can see I'm first of all converting all the numbers into string. All the nums will be converted to string because we don't need numbers. We have to just take each and every digit. So I'm converted all the numbers into string. Now I've found the value of k. What is k? K means number of digits in a number, in an element. Okay, kitne digits? Because every element has the same number of digits, right? Now I'm iterating through the one by one through all the digits. You can see. So first this, then this, then this, then this, and so on. So let's say I'm first talking about the first digit. For first digit, I'm finding its frequency. ARR of j I plus plus. क्योंकि first digit में in how many numbers, how many times the digit is present. Just like we were calculating map, right? Map कर रहे थे. Similarly, this map is there. Now for each element of map, count will be the number of times the current digit is repeating minus remaining digits which are not equal to the current digit. So id dot second multiplied by n minus id dot second, and the count will be increased. Also guys, the problem here comes is that we are actually repeating the things. Same pair is actually considered twice. For example, if you will see, when I'm considering the pairs with 1, with this, so what pairs will be there? So with 183, pairs will be 213 will be there, 517 will be there, 517 again will be there, 288 will be there. Why? Because they all have their first digit different. Okay, so means these pairs are there. But when you will even find for 517, then again this 183 will be considered. Are you getting? Now when we're checking for 517, again with 517 is 183 is considered, because it has their first digit, different. So the same pair is actually, taken twice. That is why in the count, we are returning count by 2. So that the same number should not be taken twice, right? That's another important thing. Amazing, amazing. Let's now move forward to the next problem. I hope that you have got the understanding of this problem, guys, but I can understand it is actually a difficult problem. So if you have any doubt regarding this problem, do ask that to me in the comment section, or you can also join a Telegram channel for, any type of discussion, right? Amazing. Now, guys, let's move to the next problem, which is the last problem for this, video. So, guys, see this. Oh, what I've done here. So actually this problem, guys, I have solved using 2 ways, if you will see. So the first way was DP, where we got time limit exceeded, and second was this using the combinators. So I will discuss both the approaches for this problem, right? So the problem is simply that we are currently at, so there are some staircases, right? So we actually have this number of ways problem of staircases, very famous problem of DP. So everyone must be thinking that it is a DP problem. It is actually not a DP problem, right? Because the problem says that we are some stairs. Okay, let's say this is stair number 0. This is 1, 2, 3, 4, 5, 6, and 7. This is how we have infinite number of stairs. There is no limit, right? But what you have to do, you have to reach the kth stair. Let's say k is 6. Means you have to reach the 6th stair. 6th stair, right? Now understand very carefully. You are currently at this first stair. Means initially I will say I equal to 1. You are currently at the first stair. And initially value of jump, there is a jump value given to you. That is also 0. Okay. Now you have 2 types of operations. First operation is that you can actually from the I, you can go to I minus 1. This is the first type of operation you can do. That from the current stair, you can actually go to 1 below. But this operation can be done in only 2 cases. If I is greater than 0, because if I is 0, you cannot go to minus 1. Okay, so I should be greater than 0. I should not be 0. Secondly, this operation should not be, made consecutively. Means there should not be a repeat of this operation. If you have once did this operator, let's say you were I and you made it to I minus 1, you cannot again repeat that operation to I minus 2. No. You cannot repeat it like consecutively. You can again repeat it, but not, in a consecutive manner. You cannot repeat consecutive. So what can we do? So you can actually use a second operation, where if you are at first, you can, if you are at index I, you can actually reach to index I plus 2 to the power jump, whatever jump is. And then also your jump will be increased by 1. Your value of jump will also be then increased by 1. So this is actually a case that we are handling here. So we are having a I, you will go to I minus 1, okay, and you are a I, you have to go to I plus 2 to the power jump, and once this step is taken, this operation is done, you have to also increase the value of your jump, right? See guys, the very first thing what you can think of is the brute force, or the, I will say, the DP approach, right? You can like take I, then from I you can take both the cases. Okay, I will go to I minus 1, I will go to I plus 2 power jump, and then if I will reach k, I will stop. This is something that you can actually think of, right? Although that also is, cannot be done in a very great way. The reason is that let me first open my DP solution so that I can explain you. Now, why I'm saying that that case should not be taken. The reason is that, for example, this is the staircase. Okay, and your case 2, your case 2 actually. ठीक है. अब if your case 2 means this is 0 1 2 3 4 5, your case 2, or let's say your case 1 means you have to reach 1 only, you have to reach 1 only, and you are also currently present at 1, you are present at 1. So you will say simply, okay, you are current at 1, you are present at 1, k is also 1. Okay, there is only one operation, but you have to find all the possible number of ways, find number of ways, not just this. So this is a possible way because you are present there only. Up there is one more possible way. If you will ask what you can actually do is you can actually go down first with the first operation using I to I minus 1, and then again you can go from I to I plus 2 की power 0 which is I plus 1 actually. तो आप एक बार नीचे जाओगे फिर आप एक बार ऊपर आ सकते हो because initially jump is 0 also. This is another type of operation. This is another type of operation. Third type of operation will be that you can first go up with 2 plus I to the power 0, like 2 plus I plus 2 to the power 0 because jump is 0, and then again go back. This is a third type of operation that you can do. Up guys, there is one more type of operation that you can actually do. The third type of operation that you can do is that you can actually first go down. Wait, let me think. So it was actually given here in the test case. So first you will go down, then up, then down, then up, then down. See, आप क्या करोगे? First you will go down, then you will go up. Ab here jump value became 1. Again you will go down, again you will go up, but this time you will go to here because jump value became 2. So यहाँ पे तो एक ही बार चलेगा 2 power 0. Here it will go 2 power 1, and now again go down. So in this way also you can actually reach 1 at the last. So it's not a possibility. Okay, if you are currently at k only, you can move, and you have to find multiple ways of reaching 1 or reaching k. ठीक है. अब देखो इस केस में क्या होगा? In this case, even if you can't make your base case I equal to k, you can't make your base case I equal to k, because if you are even at equal to k, you should actually check for other cases also. So how I have solved this using DP approach. So I've written this DP code. Okay, अब this DP code was having I means the current index where I am, which is last first. So this is a very confusing name, by the way. Last first is that if we have taken the first type of operation last, because if we have taken the first type of operation just before it, we cannot take it now. Jump is the value of jump currently and k is k only. अब देखो, if your I is at k, that means don't think you will just stop. Don't think that. If your I is at k, that means you will get 1 in the answer. Okay, you found one type of way, but still you have to make recursive calls. And recursive calls, before making recursive calls also, you have two cases that you have to handle. What are those two cases? Let's understand it here. This same thing I have added here, by the way. So this should not be there, but okay, I've added it. तो अब यहाँ पे क्या है कि अगर previous वाला case last first था, means if the previous operation that you have did, if that was a last first operation, means the first type of operation, or if the value of I is 0, as I told you, you can do the first operation only if the last was not the same operation and if I is greater than 0. So if I is equal to 0, or if the last operation was of the decrease type, in that case you cannot actually do the first operation again. In that case you have to always do the second operation, which is this, I plus 2 power jump. Else you can do both the type of operations, first type of operation also from I to I minus 1, and second type of operation also. Okay, this is what I am doing. अब बेस केसेस क्या है? बेस केसेस आर कि if I became greater than k. अब if I became greater than k, you can actually come down. But you can come down only once. So if I has became greater than k, and last first is also true, that means now you cannot go down. You have to always go up. Not always, but you will go at least up once. And if even currently if I is greater than k, अभी I और बड़ा हो जाएगा because of the second operation. That means it's never possible to come to k, to return 0. And even if I minus 1 is greater than k, because maybe let's say आपका I है जो k से थोड़ा ऊपर है, आपने एक बार फर्स्ट ऑपरेशन कर दिया, you made first operation, I became I minus 1. Still if this I minus 1 is also greater than k, so next operation you have to do definitely of the above, then means again you can't reach k. So this is the the corner cases where I'm returning 0, means no such of operation is present, right? So we will see this case was actually running for all the cases, but because it is a pure recursive code, it was giving TLE. And also memoizing this recursive code is not efficient, because the value of I can go up to 10 to the power 9. So memoizing this code is also not very efficient. It's not good. It will give TLE also at the last, right? So we will not actually use the DP approach. There can be other optimized DP approaches also. I will not discuss that because that they are very complex. But we have a better approach for solving this, which is actually using combinators. NCR. अब देखो ये approach क्या है? This is actually a very good approach. Okay, let's discuss that. First of all, guys, for understanding this problem, you have to first understand this function, that how we can find the value of NCR. So if you know what is NCR, NCR is actually n modulus divided by R modulus into n minus R modulus. And guys, this is actually a very efficient method for finding the value of NCR. So if you guys don't know about this method, please read about this. Okay, online you can get any blog from Geeks for You or something. So because understanding of this method is very important. And then I will discuss logic. कि logic क्या है exactly? See what the logic is. Let's understand the logic. For example, in this case, where we have to reach, let's say, let's say this one. This case, I'm erasing this maybe. So in this case, you are currently at 1, and you have to reach 6. ठीक है? अब see, you can only go up with some operations of 2 to the power something. Am I right? You can go up with operations of 2 to the power something only. Either you can first do operation of +1, then +2, then +4, then +8. Means you can do operations of 2 to the power something, right? So actually to reach 6, okay, which operation is required? So let's say अगर आप देखो कि let's say you did operation 3 times, you are currently at 1, okay? Up you did first operation, you reached 2. Then you did one more operation, you reached 4. Then one more operation, you reached 8. Up you reached 8, but you need to reach 6. So means in between somewhere you can do two times the first operation, so that eventually you can reach 6. कैसे कर सकते हैं आप? देखो, आपको पता है कि you are initially at 1. Okay, up from 1 you can actually first do a +1 operation of jump, which is 2 to the power 0, then +2 operation, then +4 operation. And by doing these operations, you can actually reach where? 8. But you need to reach where? You need to reach 6, not 8. Up to reach 6, in between somewhere, you can also do 2 times the first type of operation. Maybe here or here. Anywhere in between. But not consecutive. If you will see here, what we have done is that we have done 2 types of -1 operations, and remaining are these operations of +1, +2, +4, which will now give you 6. Means in this way you can actually reach 6. Okay, up the first thing comes, how many these type of operations you have to do. That you can find using the ceil value of 6. So if you will find the value of log base to 6, and if you will find the ceil value of that, the value will come at something 3. It will basically come at 2 point something, but if you will find the ceil, it will come as 3. This basically means that you have to do 3 times this operation of jump. 3 times jump. Let's say for other case, let's say if k is 15, up to reach 15, if you will find the value of log of base to 15, ceil value of that, it will actually give you something 4. Let's take it as 14. So for 14 also it will give you 4. So means initially you are at 1, you have to do 4 times the jump operation. How? So this is like a simple intuition that is built, because you can jump only with 2 to the power something. You can just find the log of 2, so that you can know how many this operation you have to do, right? Because initially also you are at 1. Okay, so first you have to do +1 using first operation, then you have to do +2, Because jump will also increase one by one, then plus 4, then plus 8. Okay, so you can see here there should be 4 operations. So you can see we did 4 operations: 2 power 0, 2 power 1, 2 power 2, 2 power 3. Okay, we did 4 operations here, and the final value that you will get will be is not actually 14. It will be more than 14. It is actually 16. 16. Why 16? Because if you find you are doing this operation 4 times, right? So when you will do this 4 times and already there is a 1 present, your final value will always be 2 to the power 4. You can see here also. Here we were doing 3 times. That is why final value will give us 2 power 3 8. So the final value that you will get will be actually 2 to the power 4. This value that you are getting means how much more you have did. So you want 14, you reach 16. Means you have taken 2 more steps. That means in between something, you have to make 2 times the first operation. Now where you can do that 2 times first operation? Here comes the combinators. Here comes the combination. What you will actually do is, how many possible ways are present? In how many places you can actually do the -1 operation? You can do it here, you can do it here, you can do it here, here, here. There are 5 possible way where you can do -1 operation. Let's say here, 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 here. To find all the possible combination, you will find the value of 5C2. That will give you all the possible combination where you can actually place that -1, because this is actually constant. You have to definitely do 4 times this jump operation. But where to do that -1 operation? It can be here also, it can be here also, it can be here also, it can be here also. And you have to do 2 such operations. So value will be 5C2 operations are actually possible. 5C2 combinations are actually possible, right? So if you will see what I've done here, up see there are 2 base cases. If k is 0 or if k is 4, then actually there are 2 possible ways, guys. So what are these 2 possible ways? If let's say k is 0, so if you are currently at 1, there are 2 ways to reach 0. First way is simply go like this. Okay, second way is, guys, second way is that you will actually first go like this, then you will come again back, and then you will again go back with 2 power 0 increment. There are 2 ways, right? And for 4 also there are 2 ways. How? For 4 actually you can actually simply first go first jump, then second jump, because 2 is just 2 to the power 2. There is no decrement even required, right? And if you will say that second way will be, so before moving forward in the video, let me get a chance to tell you guys about Coding 75 Pro, where we conduct live DSA classes, weekly project sessions, CS fundamental classes, one-to-one mentorship and resume review sessions. Also, you will get a chance to join our pro community where you can interact with other coders and students like you. So overall, it is a complete plan for your interview preparation. This all is just at the price of less than 20 rupees per day. So you can join this Coding 75 Pro by visiting our website coding75.com, and then we will crack great companies together. You were here, right? You were here. From here, you will go back with -1. Okay. From this back, you will take a jump of +2 per 0. Again, you will take a back with -1. Now you will take a jump with 2 to the power 1. Again, you will take a back with -1. Now you will take a jump with 2 to the power 2, which is 4 here. Now again you will take a -1 here. So guys, this is how your code will actually work here. This is how your code will actually work here. So this is how you can see there are 2 ways for k is equal to 4. But if you will see our logic will give just 1 way. That is why this is a corner case that we have to discuss separately. So there will be just these 4 corner cases. That is actually an observation based thing. Now for k is equal to 1 and for k is equal to, what you will do? For k is equal to 1, simply if you will see here also, they are saying 4 different ways are there in the test case also. And the 4 ways were actually given to you. So these were the 4 ways when k is equal to 1. First is remain as it is. Second is go down, come back. Third is go up, then go come back. Fourth is actually little complex. We will see it will be here. You will actually first go down, then up, then down, then 2 times up, then 1 time down. So eventually you will be at 1 only. And for k is equal to 2 also, guys, we have 4 different operations. You can actually check that. Try to make all the possible combinations. There will be 2 different operations for k is equal to 2 also, right? That is why for these 2 operations we have corner cases. For rest of that we are implementing our logic. Logic is that first of all we are saying what is the power of 2, means how many operations are actually needed. Let's take a different case. Let's say we are saying k equal to 22. For 22 the value of ceil log 2 k will be actually for 22 it will be 5. It will be 5. That means 5 operations are needed. Power of 2 will be 5. Okay. And also after those 5 operations, what will be the final value num that we are calculating? So see, initially we are at 1. First operation will be plus 1, then plus 2, plus 4, plus 8, plus 16. Okay, 5 operations are there. And if you will see after these 5 operations, your final value will be 32, which is actually 2 to the power 5, which is also num. Yes, you can see num we have calculated 2 to the power this 5, which is 32, because after doing these 5 operations you made your value 32. Okay, you made your value 32. Up, see guys, very carefully. The thing is that now what's the difference? Means you have made your value 32, but you want 22. For making 32 to 22, you need minus 10 operations. Means minus operation 10 times. But if you will see how many times we can actually perform minus operations, that is actually 1, 2, 3, 4, 5, 6. Means in the gaps only we can put na. So we can only perform 6 these minus operations, which is actually 5 plus 1, 6. So, but this difference is actually more than 6. Means there is no possible way for making 22 as the sum. We cannot reach 22. You can see here I am saying if r is greater than power of 2 plus 1, simply return 0. If r is less than 0 also, if r is greater than this power of 2 plus 1, means greater than this 6, return 0, because we cannot do that much number of minus operations. We can do only 6 number of minus operations in alternate ways, right? But let's say if this value k is 29. For 29 also, the value of ceil will be 5 only. Okay, this power of 2 that we are saying in our variable will be 5 only. And nums will also be 2 to the power 5, 32. But here r means what's the difference? It will be 32 minus 29. Means we just need 3. First operation. And that we can put anywhere. So out of these 6 positions, we can put anywhere. So total combination will be 6C3. Then I am simply returning value of NCR 6C3. 3 is R, this difference. And 6 is basically this power of 2 plus 1, because we have plus 1 number of operations, possible positions you can see, right? That is what we are returning here. This is how we are solving this problem using NCR. If you guys have any doubt guys regarding this problem, please do ask me in the comment section. Okay, in the comment section, or you can also ask the Telegram channel to ask your doubt. I hope that you've got the complete understanding of all these 4 problems. If you did so, please do like the video and please do subscribe to the channel. Thank you.